How to pass organic chemistry. Organic chemistry has a nasty reputation. It's not uncommon for students to hear horror stories about the class difficulty before they have a chance to take it themselves. While the class can be a challenging one, OChem isn't a nightmare it's often cracked up to be. There is less information to memorize but more processes to understand, so an understanding of the fundamentals and a good study regimen are key to getting a passing grade.
Part 1 Basic OChem Knowledge. Step 1 Learn the definition of organic chemistry. Generally speaking, organic chemistry is the study of carbon-based chemical compounds. Carbon is the sixth element in the periodic table and one of the most vital building blocks for life on Earth. Living things are made up of molecules made mainly of carbon. This means that OChem includes the chemistry that goes on inside your body every day. It also includes the chemistry that occurs inside animals, plants, and natural ecosystems. However, organic chemistry isn't limited to living things. For example, the chemical reactions involved in the burning of fossil fuels fall under the OChem umbrella because these reactions involve carbon-based compounds in the fuels. Step 2 Learn the common ways of representing molecules. OChem is a more visual area of study than general chemistry. You will be relying on drawings of molecules and compounds more often than in previous chemistry classes. Knowing how to interpret these sorts of visual representations is one of the most basic, important OChem skills. You'll need to be familiar with Lewis structures before you begin. These are typically taught as part of a general chemistry course. In a Lewis structure, atoms in a molecule are represented by their chemical symbol, their letters on the periodic table. Lines represent the bonds between them and dots represent their valence electrons. See our Lewis structure article for a refresher. One way of drawing molecules that will probably be new to you is the skeletal formula method. In a skeletal formula, also called bond line structure, carbon atoms are not shown. Instead, there is just a line to represent the bond. Since there are so many carbon atoms in OChem, this makes it much quicker to draw molecules. Non-carbon atoms are still represented by their chemical symbols. A good guide to skeletal formations is available here in the description of this video. Step 3 Learn how to represent bonds. Covalent bonds are by far the most common type of bonds you will be dealing with in OChem, though knowledge of ionic bonds, EC, is still valuable. In a covalent bond, two atoms share unpaired electrons to form a bond. If extra unpaired electrons are available, double or triple bonded atoms are possible. In both Lewis structures and skeletal formulas, single bonds are represented by one line, double lines by a double line, and triple bonds by a triple line. In skeletal formulas, the bonds between carbon and hydrogen atoms are not usually drawn because they are so common. Except in special circumstances, atoms are typically only allowed to have 8 valence outer shell electrons. This means that most of the time an atom can bond to a maximum of 4 other atoms. Step 4 Learn the basics of 3D molecular structure. Organic chemistry requires students to think about chemical molecules the way they actually exist in real life, not just the way they are drawn. Molecules take the form of 3-dimensional structures. The nature of the bonds in the molecule is the most important thing for determining the 3D shape of a molecule, though other factors can sometimes also play a role. Below are a few things to remember when it comes to the shapes of carbon-based molecules. A carbon bonded to 4 other atoms with single bonds will have the shape of a tetrahedron 4-pointed pyramid. A good example of this is the molecule methane CH4. A carbon bonded to another atom with a double bond and 2 atoms with single bonds has a trigonal planar flat triangle shape. The ion CO32 is a good example here. A carbon bonded to 2 atoms with double bonds or bonded to one atom with a triple bond has a linear rigid line shape. The molecule carbon dioxide CO2 is one example. Step 5 Learn to decipher orbital hybridization. This topic has an intimidating name, but it's not that hard to understand. Essentially, hybrid orbitals are just ways that chemists represent an atom's valence electrons based on how that atom behaves rather how it is drawn. If an atom has a certain number of unpaired electrons available for bonding, but tends to form a different number of bonds, it is said that it has hybrid orbitals to make up the difference. Carbon is a perfect example of this. Carbon atoms have 4 valence electrons, 2 in the 2s orbital and 2 unpaired ones in the 2p orbital. Since there are 2 unpaired electrons, it might be expected that carbon will form 2 bonds. However, experiments show that the paired electrons in the 2s orbital form bonds even though they are not unpaired. Thus, we say that the carbon atom has 4 unpaired electrons in its hybrid orbital. Step 6. Learn the basics of electronegativity. There are many factors that can determine how two molecules react with each other in OCHAM. However, electronegativity is often one of the most important factors. Electronegativity is a way of measuring how tightly a given atom holds its electrons. Atoms with high electronegativity tend to hold their electrons tightly and vice versa for atoms with low electronegativity. See our electronegativity article for detailed information. As you go up and to the right in the periodic table, atoms gain more electronegativity. Hydrogen and helium are not included. Fluorine, the atom in the very top right, has the highest electronegativity of all. Because electronegative atoms want more electrons, they tend to react by grabbing available electrons on other molecules. For example, atoms like chlorine and fluorine often appear as negative ions because they have taken electrons from other atoms.